Okay, so we have this interesting question under optics. It says a ray of light strikes a plane mirror at a glancing angle of 55 degrees. Calculate the angle between the incident and reflected ray. So we have a diagram here that really illustrates what you get when a ray of light hits a plane surface. So here we have the source of light, and of course it is going to create the ray, and you call that ray the incident ray. So the ray hits this plane surface, which is acting as our mirror, and we now have a point of incidence. So this is a point of incidence here, and at that point of incidence we are going to construct a normal, and the normal will be perpendicular to the plane surface. What does it mean? It means it's going to be 90 degrees on the right hand side. We're going to have an angle of 90 degrees on the right hand side and an angle of 90 degrees on the left hand side. So from here to here will be 90 degrees, and also from here to here will be 90 degrees for our angles. And now, since you have constructed a normal, the angle between the normal and the incident ray, we'll call that angle the angle of incidence. So this is the angle of incidence. And of course, when the incident ray hits this plane surface, it's going to be reflected this way. So when it reflects, don't forget that it's going to reflect starting from that point of incidence. Also, it's reflecting this way, and when it reflects this way, creating the reflected ray, is a reflected ray, is going to make an angle also with the normal, and they call that angle the angle of reflection. And in this case, the angle of incidence will always be equal to the angle of reflection. So if this incident ray makes an angle of 30 degrees with the normal, it means it's going to bounce back or bounce off the plane surface as a reflection and creating a reflected ray, and it's going to make, and the reflected ray will make an angle of also 30 degrees with the normal. Since the angle of incidence is 30, then the angle of reflection will also be 30, because the angle of incidence and the angle of reflection are always the same, provided the ray hits a plane surface. And then we have this angle here. This is the angle that the incident ray makes with the plane surface, makes with the mirror. So that angle is called the glancing angle. It's also the same, it's identical to the one on the right hand side. Also, you can also see the glancing angle is the angle that the reflected ray makes with the plane surface or the horizontal. That angle is called the glancing angle. And mind you, we know that this angle here, glancing angle, plus the angle of reflection, plus the angle of incidence, and the angle of this other glancing angle gives us 180 degrees, because we know that angles on a straight line sums up to 180 degrees. You have your straight line, and then you have 4 angles, 1, 2, 3, 4 on the straight line. Those 4 angles definitely will add up to 180 degrees. And don't forget that the angle here, every angle, the angle of incidence plus the glancing angle adds up to 90 degrees. And on the right hand side again, the angle of reflection and the glancing angle on this other side also adds up to 90 degrees. This one adds up to 90 degrees, this one adds up to 90 degrees. So that's it. So we can now go straight to the question, since I've given you the foundation of reflection of light. So they said a ray of light strikes a plane mirror at a glancing angle of 55 degrees. At a glancing angle. So I'm going to draw let me assume that this is my plane mirror, and I have my incident ray coming, and of course I'll have to draw my normal immediately. So this will be my normal here. Your normal will be drawn at the point of incidence. So this is my normal. So I have my normal. This is my reflected ray. So this is my incident ray rather. Then the ray will be reflected this way, starting from that point of incidence. Incident ray and reflected ray and my normal, making an angle of 90 degrees to the right and an angle of 90 degrees to the left. So this is my glancing angle according to the diagram I showed you before. So this will be the glancing angle. So definitely this is my glancing angle of 55 degrees. So I'm writing 55 degrees. So and they said calculate the angle between the incident and reflected ray. Okay, this angle and this angle are the angles between the reflected ray and the incident ray. Of course, this is the angle of incidence and this is the angle of what reflection. And we know that the angle on the left hand side, that's from here to here, the angle of incidence and the glancing angle must sum up to 90 degrees. So my angle of incidence, I, plus 55 degrees must give me 90 degrees. So collecting like terms, I will now be equal to 90 degrees. D plus 55 becomes minus 55 degrees. And I now have my I to be equal to 90 degrees minus 55 gives me 35 degrees. So my angle of incidence here is 35 degrees. And definitely in this case where you have the ray of light hitting a plane surface or mirror, the angle of incidence must also be equal to the angle of reflection, which is this angle here. So I'm going to write 35 degrees and I'll sum them up. So the angle between the reflected ray, this reflected ray, and the incident ray will now be the sum of these angles. After all, just by looking at it, these two angles are the angles between the incident ray and the reflected ray. So I'll just sum them up. 35 degrees plus 35 degrees gives me 70 degrees as the value of the angle between the incident ray and the reflected ray. So very simple.